Hello everyone, my name is Malik and welcome back to my channel. Today I'm gonna share another interesting tutorial related to deploy three-tier application on Kubernetes cluster. In this simple application, there is a registration page which allows users to register, or there is a login page which also allows registered users to log in this application. And finally, by click on logout, you can end the login session. Let's start and see how we can deploy this three-tier application on Kubernetes cluster and play with many components of Kubernetes cluster. Stay tuned. When we speak about three-tier application, it is something like this picture, web or presentation layer, where in your browser you see that. The next one is data tier, where our data is recorded in database. When a user registers on our website, all the credentials will record on our database. And finally, the next tier that is located between the presentation and data one, it's called application or backend layer, which do all the process in your application. For example, when you see the login page, when you click on login button, your information will send to the database one. But at first, in the middle, the data will extract from the form and will check if they are exist on database or no. If they are exist, we'll extract them and then let you to log in the application. For our application in database layer, I'm using MySQL database, and for server layers, I'm using NodeJS. Here is our application. As I mentioned earlier, it is written by NodeJS. You can find the link of this source code in description of this video. Here you see there is a folder, it's called .env. All the environment variables related to this application mentioned here. For example, database name, database address, database user and password, and listening port for this application. We will talk about them later, especially when we want to deploy this application on Kubernetes cluster. Let's run this application and see the result. Before that, in this file app.js, if we going down, here you see the listening port is hard-coded here 5000, and also you see it is defined in environment variables. If I check it here again, you see the port is 5000. When the application is running, at first it will check environment variables. If it couldn't find, it will go and pick up this hard-coded port. Let's go into terminal by running this command node app.js, or if you install nodemon by typing npm start, it will run. As you see, it is started on port 5000. So if I go to my browser, in the browser by typing localhost and the port number 5000, you can reach to the application that is running on port 5000. So if I click on login, if you have already registered, you can use your username and password, or no, you can click on sign up and enter your data and register to application. But at the moment, I didn't bring up a database, only I did run application, this section, app tier. Also, I need to bring up a database and connect application server to database and see if they are working well. Then we can go forward and prepare image for this application and deploy them on Kubernetes cluster. Let's bring up a database by Docker and connect it to this application. Before that, let's have a look on Docker Hub and search for MySQL image and see how to use it. In Docker Hub, I search MySQL. From the result, click on the first one. Let's going down and see how to use it. As you see here, this is the command we are going to use it. Docker run, give it a name, and also by dash lowercase e, we define what is the root password. Because if we don't define that, we don't know how to connect to this database. Yes, it can generate a random password and we have to connect to MySQL container and find it, but we don't want to going in this way. Here just we define and give it a password and also which version of MySQL we gonna run and use it for our application. Let's copy this one and back to terminal. Let's stop application and paste the command here. Let's give it a password, the same password that I defined it here in environment variable in the application. Just at the moment leave them as is, and later in Kubernetes section I will talk more about them. Let's back to terminal again. Okay, so just this one, and let's give it a name. Name it MySQL, and for the version I'm using 5.7. Let's add another option here. Port, we define the port -p, it means port, and we'll connect this port from my computer to this port on container. So let's run it. Now the database is running. How we can connect to MySQL database and define a database and tables there? One way, we can connect directly by CLI, and another way is using PHP myadmin. At first, let's using by CLI, just running docker exec-it MySQL. This is the name of the container /bin bash, and we connect to MySQL. Just type MySQL -u root -p. It will ask the password. What was the password? And the password, we gave it in the command line. Here you are. We are inside MySQL database. If I type show databases, here are the default databases inside MySQL. Exit from here and let's bring up a PHP myadmin and connect to database and define our table and define the records that we need for our application. Let's search PHP myadmin in Docker Hub and see the variables and the commands. We can use this command, add its usage with external server, because MySQL is another server, so we can use this one. Copy this one and back to terminal and paste it here. it will bring up phpMyAdmin by Docker. Here you see there is environment variable. dbHost, it means the address of the MySQL server. At first, let's comment this one and find the IP address of MySQL server. Just type docker inspect and MySQL. This is the name of MySQL container. Here you are. Here is the IP address of MySQL server. Clear screen, bring the command here, remove comment, and change dbHost to this IP address. Let's enter. It is created. So let's go into browser and access to this port and see phpMyAdmin. By typing localhost and the port, we can access to welcome page of myphpAdmin. Here we have to use the root as a username and MySQL password. As you remember from some minutes ago, we assign a password to MySQL server. Let's connect to it. Here you are. We are connected to MySQL server. Let's import my database as I prepared by myself. Let's select initial database that I want to import and import. Look here. This database created here. If I click here, there is a table. It's called users inside that. And inside this table, if I check a structure, you see the records inside that. So far, so good. So as you see at the moment, MySQL is ready, and let's bring up our application again. Just type NodeJS and app.js like that, or npm start, or application will bring up. Look here, application is ready on port 5000. Let's back to browser again, and here just type localhost and port 5000. Here our application. If I click on login and on sign up, just type here, for example, malik@example.com. Here are the credentials that I want to register. Just register. Look here, your data submitted successfully. If I back to phpMyAdmin, if I go to browse, look here, Malik Nejat, this email and hash password recorded here. Let's back to application. If I back to login, if I use the email that I already registered and the password and login, look here, I connected by registered username. If I refresh here, nothing happened. Yes, I am connected to it. If I click on log out, my session will be done. And if I click again on login, need to enter the credential again to connected my session. Let's back to terminal, stop the server, and just type docker exec-it mysql/bin bash, connected by CLI to MySQL, and by this command and password I am connected to MySQL by command line, and also show databases. Look here, this is the name of my database. So everything is good, and here we learn how to bring up my application, how to bring up MySQL database, and how to use phpMyAdmin to connect MySQL server and manually create our database, table, and records. So let's going forward and bring up our Kubernetes cluster and do all this step on Kubernetes cluster. In this section, at first, we are going to make an image from our application, then push it to an image repository. For example, here I'm gonna use GitLab as an image repository. So at first, let's go into terminal, clear a screen, and just let's do ls-latr. Here I have created a Docker file. Just let's open it. Here I'm using a node image as a base image. As you see in second line, I'm using work directory. Here is the work directory on image. In the third line, as you see, it will copy this file package.json and also package-log.json to image. Let's open this file. As you see here, there are some packages that need to be installed on this base image to let our application run properly. For example, we need bcrypt.js, we need EJS, we need .env, we need Express, and so on. In the next line, you see it will run npm install. What this one do? It will go and run all the packages that needed for this application that are listed in this package.json file. After that, we'll copy all the files and folder from here to the image. Then we'll expose our application to port 5000 because our application will run to this port. And finally, here by running node app.js, we'll put our application in running mode and we'll listen to port 5000. Okay, our Docker file is ready and we need to build an image. Let's back to browser and connect to our GitLab account. I have created a project here. Let's switch inside it, and here, as you see, it's empty. From the left side, click on Deploy Container Registry. You see there are no container images stored for this project. Let's going down. As you see, there are 3 commands that we have to follow to prepare our image and push it to this repository. The first one will log in to GitLab registry. Copy this one, back to terminal, just run this command, check my username, yes, and need my password. Login, succeed. Back to browser, copy the second one. This one will build an image from my application. Back to terminal, paste it here and give it a name after the project name. For example, app-login version, for example, 1. Enter. This one will go and will create an image with this name and with this version. Okay, image build. So let's back to browser and copy the last one. This one will push an image to GitLab registry. Copy this one, back to terminal, paste it here, and also we need this one at the end of this line. Okay, so just enter. It will go and push the built image to GitLab registry. Okay, it's done. Let's back to GitLab project. Let's refresh here. You see app login with this tag version 1 pushed here. So the image is ready, and now let's going to build our Kubernetes cluster. In this section, I'm going to build a Kubernetes cluster. This is for whom that still has issue to bring up a simple Kubernetes cluster. For this one, I will follow these steps. I gonna to create it on AWS. As you see, I gonna to bring up an EC2. For this one, I will create a VPC. Inside VPC, I will create subnet, public subnet, because I wanna connect this public one to internet by internet gateway, and also I will create a router to route or packet from EC2 to internet through Internet Gateway. Here is the Terraform code. Also, you can access to this Terraform code by the link in description. Let's run it and bring up our EC2 instance. Just type Terraform plan and see what will happen on AWS. As you see, it will create an EC2 with this private IP, but at the moment the public IP not clear because we have to deploy it. So just type Terraform apply and type yes. As you see, with the miracle of automation, an EC2 created quickly. Let's run it again, type yes, and will show us the public IP. Let's copy this one and connect it through terminal. Connect to EC2 by SSH, yes, and here you are. We are connected to created instance. So just type sudo -i and switch to root user. Here, with some command, quickly we can bring up a Kubernetes cluster by K3s. Just using this command. Now let's check the K3s version. As you see, the latest Kubernetes version installed. If I type kubectl get node, as you see, still there is an issue with communicate to cluster by kubectl. So we need to fix it by the following commands. At first this command, so it seems we need to create this folder and dir this one and run the command again. It works. And the second command is this one. Now let's run kubectl get nodes again. As you see, the issue fixed and Kubernetes working properly. Let's do like this, and here is the internal IP of the Kubernetes cluster. Let's check if Helm is installed or no. As you see, Helm still is not installed. We have to install it. If I go to official website of Helm, as you see here by this script, we can install it. Just copy this one, back to terminal, next command, paste in terminal, and last one, just check Helm version. As you see, the latest version of Helm installed properly. So let's clear the screen. And also, if we need to use GitLab CI/CD, we need to connect our cluster to our GitLab account. If you don't know how to connect GitLab account to Kubernetes cluster, I have another video about it, and I pin the link of that above this video, and you can follow that and you will see how we can do that. But here, just let me go to my GitLab account, and through one of the repositories that I prepared for this project, I will connect it to my cluster. For quick connection, just I type in Google connecting a Kubernetes cluster with GitLab, and from the result click on first one. So from here in second line, you must first install an agent in your cluster. Click here, and let's going down, and in the repository, in the default branch, create an agent file like this. Copy this one back to GitLab account. Here, just click here and new file. Copy that one here, and we have to select a name for our agent. Select this name and commit change. As you see, this file created. Let's back to the root. Here, if I click here, this is config.yaml, and it's an empty file. Later we can configure it. At the moment, leave it as is. So from the left side, go to Operate, click on Kubernetes cluster, connect to a cluster. From here, select the agent name and register. Here, install using Helm or install manually. In our cluster, we have Helm, so just copy this one and back to terminal and paste it here. So just type Helm, repo list. You see GitLab repository added here. So let's back to GitLab account, close this one and refresh page. As you see, our GitLab account connected to our Kubernetes cluster. Let's have a quick test to see if we run a CI/CD command here, it will run on Kubernetes cluster. At first, let's go into terminal. Here, if I type kubectl get node-oy, enter, here is the output. Let's back to GitLab account. Let's go into root, and here we need to create a CI/CD file. Let's create a file called .gitlab-ci.yml. Here the sample code. It will go and run this command on our cluster. So let's save it. As soon as I click on commit change, this file will be run. Let's commit. This file has been successfully created. From the left side, click on build and pipelines. Here show us it's failed. Let's see what's the problem. Let's check. This connection is not exist. Let's back to code. kubectl config use context. Yes, this is the problem. Here it should be the name of our repository. Let's edit it. What's the name of our repository? app-k8s. app-k8s. Let's save it and commit. As you see, it will go and run pipeline. From the left side, let's click on pipeline. It's in running status. Click here. Click on deploy. It is in running state. As you see, again we got failed. It seems today I'm not a lucky person, but let me check it again. Maybe there is a typo. Here it should be the agent name. K8s connection. Let's from the left side going to operate Kubernetes cluster. Oh, as you see, the name is K8s connect, not connection. So let's fix it. Back to code, click here, edit in pipeline editor and connect. And it should be fixed. Let me commit change. It will go and run pipeline. From the left side, click on pipeline. As you see, it is in running status. Click here, click on deploy. Let's see what will happen. Yes, it works. You see, kubectl get nodes here, and see, yes, this is the internal IP. This is the same as you see here and this version. So it seems connection between GitLab and Kubernetes cluster is successful, and we could run a command through CI/CD and it works properly. So as you see, our Kubernetes cluster is ready, and now we have to prepare our configuration file, bring up our application manually on Kubernetes cluster. To find out how to bring up a container inside Kubernetes cluster, it is better to give you a perspective of Kubernetes cluster. Here we assume this is one node of our Kubernetes cluster, and it's the IP address of this node. Here we're gonna to bring up a container with the build image here. For bring up a container, there is a concept in Kubernetes, it's called pod. Pod is the smallest component in Kubernetes. Assume pod is like a box and we bring up our container inside the pod. Normally in Kubernetes, we never use the name of container and we use the name of pod. In each pod, we bring up a container, but sometimes we can bring up multi-container for some specific purpose. But at the moment, we assume in each pod only there is one container. So for bring up our application, we need to bring up a container inside a pod with using the image that is container registry. So let's bring up a pod here, and this is our pod. We name it app with using the sample version 1 image. When we bring up a container or a pod here, it gets an IP from the Kubernetes cluster. So our application now is up, and how we can access to this application. Here there is a user and want to access this application. How can do that? Is it possible to use this IP in browser and access it? The answer is no. Let's clean these lines because the pod is alone inside the cluster and only is accessible from inside the cluster, no from the external. And also, if for any reason the pod restarted, its IP will be changed. It means the pod never keeps a permanent IP. For solving this problem, another concept to play and called services. The service is a logical component and its IP is permanent and never change, and we put service in front of the pod. So for access to application here, we have to access this IP address through service. We have some different type of services. By default, it's called cluster IP type, and from its name you can see it is accessible only inside the cluster. For example, you have some application inside the cluster and they want to communicate with each other, so only they can communicate through cluster IP service. So still our issue exists. How we can overcome our issue? We want to access it from the external. How we can do that? There is another type of services. Before going forward, this port called port and this port called target port. It is important in configuration. So for access from outside, there is another type of service is called node port. When bring up a node port services, the service will attach a port to the cluster node that will be one by one mapping between service and that port. The problem solved, and from the external, just we type the IP address of the node, and using the node port, we can access to application. So far, so good. But still, there is one thing that I need to mention it. When bring up an application here, need to pull image GitLab container registry. But as I told you before, for access to container registry, we need username and password. So in the configuration, if using them in clear text, it's not a good way. So what we can do, there is another concept inside Kubernetes cluster. It's called secret. We can define a secret and put the credential inside the secret and call it inside the pod configuration. So we need three manifests. One manifest to bring up a pod, one for secret to keep credential, and one service which type node port to allow us access application from outside. Here maybe a question come to your mind. If for any reason this pod going down, what will happen? The answer is simple. Our application will go down. What is the solution to resolve this issue? Normally, in a state of using pod, we are using deployment. In deployment, we can define how many replicas of this pod be in service. For example, we can define 3 pods. If one of them is going down, the others continue to working, and also the one went down, automatically a new one will be created. So in a state of using pod, we are going to use deployment. As also remember for some minutes ago, when we did bring up our application, it was listen to which port? To port 5000. So here, when we define our configuration, we are using port 5000 as a target port. Leave the subject as is, and let's going to speak about MySQL pod, and then we will create MySQL and application in practical. In the start of this session, we have created a MySQL server on Docker by this command. We define environment variable by adding like this in the command. So in Kubernetes, how we can create like that? At first, we have to take out this environment variable from the command. Now you see the command is more simpler. At first, let's take care of this one. As you see, it is credential. It's a password. So for take care of password, also if you remember, we have to use secret. By using this command, kubectl create secret, and which type generic, give it a name, and then define this one from literal password, it's a key, and also this one as a value, and also the other parts of command will create for us this secret configuration file. As you see, this is a clear text. How we can take care of that? We can use a file, called it, for example, secret.txt, and then in a state of this one using -- from file. So it will go and take password from the file and put it in configuration. Still, we need to make another change. Let's go here. So it is better to using like this dash dash from file, define a key, and then the value that is stored in this file. So when we run this command, it will create such file. In data section, you will see root password as a key and encode of the password. The encode is base 64. If I want to see this is correct, just by this command, it will show us the correct password. And we see everything is okay. Here we learn how to create a secret file for MySQL root password. Now we have this command, and also we need to change it to Kubernetes command. By using this command, kubectl run MySQL, and using this image, it will create such file for us. This is simple configuration for MySQL. What we need to do, we need to add secret in this file. The secret that we have already spoke about it, we have to put it in this configuration. Also, we need another thing. We need, after MySQL pod created, automatically create for us database, table, and records. This is like a script file. So we need to have a script file and define our database name and which table we need and which record needs for our application. Based on configuration in our application, we need a database with this name in our MySQL. Also, we need these records: ID, first name, last name, email, and password. And also we need ID as primary key. So for this one, we have to create such a script file. For MySQL, every script file has this extension .sql. You can name it everything you want. Here I'm using init. So in this file, I define create database. If not exist with this name, then switch to this database and then create these records. This is MySQL command, and here we have no time to speak about the MySQL commands. You can read it by yourself and search on internet how you can use MySQL commands. So let's going forward. So here another subject, it's called config map, comes to play. With config map, we can define a configuration and then attach it to our pod or deployment. For create a config map, just we can use kubectl create config map. This is abbreviation of config map, and then give it a name. So here I am using this name. Then from file like secret that we already spoke, we can use from file. So it will go and get all the data, all the content of this file as a configuration file, and then we can attach it to our pod configuration. So as you remember, this is our simple configuration for MySQL pod. We need to inject our secret and config map to this configuration. At first, for secret, here our secret configuration. So we need to have this password as environment variable here. By this section, we wanted to define environment variable. What is the name of environment variable if you remember from here? This one. So we need to use this environment variable in configuration. So name it this one. So we need a value for it. The value from, where is value located? Value from secret reference. Here is the name of secret file. What is the key file here? This is the key file, and automatically will take this password and put it in the configuration as an environment variable. So it looks like this one. Now it's a time for config map. By the command that showed you some minutes ago, config map will be created with the content of this file. We need to push this file that is located in config map to where? To pod config. How we can do that? If we go to internet and just in Google search Kubernetes config map file mount, it means how we can mount the content of config map to pod configuration. From the result, click on the first one, and here just find this section, populate a volume with data stored in config map. Here you see we have to define a volume, give it a name, every name you want, then this key, config map, provide the name of the config map containing the files you want to add to the container. So here the name of the config map. Then after this volume created, we have to mount it to our container. So just by volume mount, name it this name, what's the name of the volume, and where we have to mount it. So let's back to our presentation. Here we have to define a volume, give it a name, and then this key, config map. What's the name of the config map? Here we use this name. So you see we add it here. So here the volume. We need to mount it to MySQL container. So volume mount, here the name of this volume, and where we have to mount it. We have to mount it to this directory. The Docker entry point -init db.d is used to store shell or SQL scripts that you want to be executed when a container is started for the first time. So here is the complete configuration for the MySQL pod that we need to run. As you know, when we bring up a pod, it has a temporary storage. And if for any reason the pod failed or going down, the storage will be gone and you have no access to your data anymore. So here, having a persistent storage is mandatory. Here, another subject comes to save your data. They called persistent volume and persistent volume claim. The persistent volume will create by Kubernetes administrator. This persistent volume is look like a pool of volumes. Sometimes the volume is located on local server, sometimes on fiber channel, and sometimes are located on cloud storage. So when we bring up a pod, and if we need persistent volume for all containers in our pod, we need to request of persistent volume to assign volume to our pod. To request a volume from persistent volume, we are using persistent volume claim. For example, you claim 2 gigs and the persistent volume will assign you this amount. Here we have no more time to focus on persistent volume and persistent volume claim, and if you want to learn more about them, you can go directly to the official website of Kubernetes. So let's go into Google and just type Kubernetes persistent volume and search for it. From the result, you will find the first one is the official website for Kubernetes. Just click on it, and here is the good resource to learn more about persistent volume and volume claim. So if we go down here, you will see how to create a persistent volume. And also here you see how to create persistent volume claim. And here you will see how to use them in your pod. So let's go into terminal and bring up our MySQL pod. If I want to summarize everything that I told you about MySQL pod, I need to bring up a persistent volume and persistent volume claim, a secret to keep MySQL root password, and also a config map to keep initial script for configuration database, table, and record on MySQL. And then we need to bring up MySQL pod. After the pod is ready, we need to bring up a cluster IP service to let us have a static access to MySQL pod. And after MySQL is ready, we can bring up a phpMyAdmin pod to check database, tables, and records on MySQL database. This one is not mandatory and you can skip off this one, but if you want to troubleshoot, it is better to have it. Let's start in terminal and bring up all these objects. In my cluster, just I did clone my repository, and let's switch inside that. Here, all my projects are here, and at the moment, I'm using the last one, cd number 4, and here all the configuration for MySQL and phpMyAdmin. For MySQL pod, at first I need to deploy PV and PVC. Here, let's open PV and PVC. Look here, this is persistent volume configuration. As you see here, the storage is located inside cluster. So let's deploy it. kubectl apply -f db-pv.yaml. Look here, kubectl get pv. It is created here. And let's open PVC. You see here, also we requested from persistent volume to give us 2 gig. So let's deploy PVC also. As you see, it is created. And let's get PVC. As you see, a status is bound. It means bounded with PV. For the PV, you see it is bound. Before PVC created, as you see, the status was available. So the storage is available. So when we run PVC, it is bounded with that. It means get capacity from PV. Okay, let's clear the screen. The next one is secret and config map. Cat db secret. Here the secret that we have created. I spoke about it some minutes earlier, and just going to apply it. kubectl apply -f and db secret. Sorry, clear screen, and we need db initial db config as a config map. Cat db initial db config. Here is the content of this config map is to create a database table with this name, users, and also this record. So kubectl apply -f and the config map name. Let's apply it. Okay, good. So let's check our component. You see here PV, PVC, secret, and config map deployed. Now let's going to deploy pod and service. ls cat db pod. Here is my pod. As you see here is the environment variable. We'll go and read the password from the secret. Also mounted this volume. You see, this is a config map mounted here to this folder. We spoke about it. This is a place that all scripts related to MySQL will run. And here also is related to persistent volume. Let's apply it. Apply -f db pod. This one also created. It's time to deploy MySQL service. Let's clear a screen. Cat and this one. Look here, it is cluster IP and target port is 3306. kubectl apply -f MySQL service. Okay, clear a screen. kubectl get pod. Here MySQL pod is running. Services, MySQL services is running. If I run kubectl describe service and service name, here will show you the endpoint. Endpoint is the MySQL pod. If again I type kubectl get pod -o wide, look here, this is the IP of MySQL pod, and if you compare it here, they are same. So it means this service control this MySQL pod. Let's again show you the pods. Let's connect to MySQL pod. kubectl exec-it pod name and /bin/bash. At the moment, I am connected to MySQL container. Just type MySQL-u root-p and the password I did define in secret. Look here, I am connected to it. So if I type show databases, look here, this is the database name we did define in config map. Let's exit from here and clear screen. Now it's time to bring up PHP MyAdmin and connect it to MySQL. When a pod wants to connect to another pod or service, it should have the DNS name of destination service or pod. So if PHP MyAdmin wanted to access the MySQL service, need to use MySQL service DNS name. How we can find out that? Just MySQL-service name dot, it is located in which namespace. At the moment it is located in default namespace, and dot the key name of service SVC and cluster DNS name. Here is cluster.local. So we have to use this one. If you remember from starting this session that we deployed PHP MyAdmin manually, we need to define these two environment variables. One of them is MySQL port and another one is MySQL hostname. So let's back to terminal. At first, let's check PHP myadmin config. Look here. Here is two environment variable. MySQL service default. This is the address of MySQL service, and this one is the port. kubectl apply -f and this configuration name. Here you are. The config map applied. The next one is pod and service. Here is PHP myadmin pod. Open it. Look here. Here is the environment variable. Here it will go and read environment variable from config map. So kubectl apply -f and let's apply the service configuration. kubectl apply -f and PHP myadmin service. kubectl get pods. Look here, two pods, one of them MySQL one and the other one PHP myadmin. And for services, here MySQL service and PHP myadmin service. As you see, here is the port. We can access it from outside. For my cluster, I did open this port in firewall. Let's go into browser. Here is my cluster public IP and this port. Here you are. We are connected to PHP myadmin. For username, we are using MySQL root user and also the same password we are using for MySQL root username. So here and login. Here you are. We are connected to PHP myadmin, and in left side here is my database name. If I click on it and here the table name, click on it, and from the right side click on a structure, you will see the records ID, first name, last name and email, and the ID is the primary key. So in this section we learn how to bring up MySQL and PHP myadmin and how to connect both of them together. Now it's time to bring up our application and connect it to MySQL. For our application, we need deployment and service. If you remember from the starting of this session, our application needs some environment variables. We need these variables. What's the name of our database? What's the address of our database or MySQL server? And what's the username and password, and on which port we can connect to database. Also on which port our application is worked. So we need to define these variables in a config map except the password. For the password, we have to create a secret. We need secret and config map. So let's back to terminal. Here, as you see in our files, we have an application config and application secret. This is for config map and secret, and also a deployment and a service. So let's cat deployment. Look here. We need to define an image and also config map and secret. For the image, if I go to Gitlab, in my repository from the left side, going to deploy container registry, you will see our image. If I click this one and back to terminal, and let's edit this one and update this image. If you remember, it is version 1. Also for environment variables, here we mentioned config map and secrets. Let's save it. So let's cat application secret. Here the configuration, And also for the config map, here you see the database, host name, user, and etc. For the host, here is the DNS name of MySQL service. So let's kubectl apply -f app-secret and also config map. Both of them created, and now let's provision deployment. We got an error on line 18. Vim app-deployment. Okay, so we need to fix this one and run it again. Okay, nice. And kubectl apply app-service. Sorry, I forgot to add -f. Okay, done. If I do kubectl get deployment and let's get paths, image pool backup. You see, we got an issue on image. Why we got this error? Kubectl describe pod and the pod name. When it wanted to download the image, you see, forbidden. It seems at first we have to log in to GitLab registry because our repository is private one. So we need at first log in to repository. In Google, search for pull an image from a private registry. Search for it. From the result, click on the first one, and here you can find the proper information how to create a secret for registry credential and how to use it in pod or deployment. In this page, if you see here, create a secret by providing credentials on the command line. Here is a command that you can create a secret file. In this command, you have to define the registry address. For the GitLab is registry.gitlab.com, your GitLab username, your GitLab token, and your email address. I did replace my credential on this command, and I have created this file, registry credential YAML. So kubectl apply -f this file. I got an error. It seems in metadata.name we cannot use underscore. Let's fix it and change the name to like this. Save it and apply it again. Okay, created kubectl get secret registry credential applied. If I back to document, here you see how we can use it in pod or deployment. Just copy this one, back to terminal, Vim application deployment, and add it here. But let's update the secret name. It should be like this. Save it and kubectl apply -f app-deployment. It's updated. Kubectl get deployment. You see, one by one. It means one replicas of our application is running. Kubectl get pod. Look here, this one is in running status. Nice. So let's check services. Kubectl get svc. Here is the application service and running on this port. Okay, let's go to browser. This is the public IP of my cluster and this port. Here you are. Our application is running on Kubernetes cluster. Now we have to test it and see if it's connected to our database or no. Here is the database. At the moment is empty. Let's create a user on our application. Login, sign up. I did fill all the credential and click on register. You see your data submitted successfully. If I go back to PHP my admin and refresh here, you see Malik, my last name, and this email and this encrypted password added here. So if I back to application and click on login you see I am connected to my application. As you see, my application and database connected together and work properly. In this presentation, we have learned how to prepare our configuration file for deployed 3-tier application on Kubernetes cluster. Some subjects remaining, and in next part I will explain how to add ingress to our application and how to a stateful set for MySQL server, and also how to deploy it by CI/CD and some other subjects. If you like this presentation, please don't forget to comment your feedback and like it. See you in next one.